Next Generation Science Standards. The purpose of the PowerPoint is to provide an overview of the Next Generation Science Standards that Maryland has adopted. This document was developed and produced by the Maryland State Department of Education through federal funds. The Towson University Teaching Modules Development Team was led by Debbie Gartland, Project Director. On the team were Roberta Stroh-Snyder, Val Sharp, Michelle Pascoe, Lenore Chapman, Jessica Kirchen, Jessica Moore, Rebecca Malloy, and Darlene Fuster. Thank you to all the content experts and others who provided feedback on the teaching modules as they were under development, including Towson University faculty, staff, and teacher candidates, and school system and MSDE personnel. Here's Activity 1. Read these quotes to yourself. What do you think each means for you as future educators? Let's spend a few minutes discussing what you think. Keeping our discussion in mind, let's watch this video. It's an overview of the new science standards called the Next Generation Science Standards, known as NGSS. As you watch, note the compelling reasons for our students to be better prepared in the fields of science. We will discuss what you heard after the video. The National Research Council, or NRC, which is part of the National Academy of Sciences, along with the National Science Teachers Association, the American Association for the Advancement of Science, and Achieve, completed a two-step process to develop the Next Generation Science Standards. Step 1, getting the science right. The NRC began by developing the A framework for K-12 science education. The framework was a critical first step because it is grounded in the most current research on science and science learning, and identified the science all K-12 students should know. To undertake this effort, the NRC convened a committee of 18 individuals who are nationally and internationally known in their respective fields. The committee was composed of practicing scientists, including 2 Nobel laureates, cognitive scientists, science education researchers, and science education standards and policy experts. In addition, the NRC used 4 design teams to develop the framework. These design teams in physical science, life science, earth-space science, and engineering developed the framework for their respective disciplinary area. Step 2. States developing next-generation science standards. In a process managed by Achieve, states led the development of K-12 science standards that are rich in content and practice and arranged in a coherent manner across disciplines and grades to provide all students an internationally benchmarked science education. The NGSS are based on the framework and will prepare students for college and careers. The NGSS were developed collaboratively with states and other stakeholders in science, science education, higher education, and industry. This process produced a set of high-quality, college and career-ready K-12 next-generation science standards ready for state adoption. The standards were completed in April 2013. This slide depicts a visual of the partners who developed the standards. The K-12 framework proposes a new approach to K-12 science education that will capture students' interest and provide them with the necessary foundational knowledge in the field. The framework provided guidance to lead states and writers facilitated by Achieve in developing the NGSS. It is important to note that there was no federal government involvement in the development of the framework nor the NGSS. The standards are not part of the Common Core. So what's the difference between how science will be taught using the NGSS? Instead of learning about the science idea with the NGSS, students will have to figure out how and why science works. The standards are a set of performance expectations in science, which place particular emphasis on content, critical thinking, and science and engineering practices. The Maryland State Board of Education adopted the NGSS in 2013, noting that the new standards provide additional rigor that will prepare Maryland students for college and career. A number of Maryland educators were involved in formation of the standards. Maryland was the fourth state to adopt the new standards. Maryland schools have started implementing the NGSS and building curricula aligned to the standards. Here is a visual of Maryland's NGSS implementation and planning document, which then State Superintendent Dr. Lillian Lowry presented to the members of the State Board of Education on April 22, 2014. Notice that full implementation is expected to occur during the 2017-2018 school year. Let's take a few minutes to discuss what you are seeing in your schools in terms of implementation. Let's watch another video. Why is now the right time for the NGSS? The framework illustrates the three dimensions of science education, advocating for pedagogy that utilizes the practices and cross-cutting concepts to teach the disciplinary core ideas. The National Academies Press offers free downloads of hundreds of related publications. The framework describes a vision of what it means to be proficient in science. It rests on a view of science as both a body of knowledge and an evidence-based model and theory, building enterprise that continually extends, refines, and revises knowledge. It presents three dimensions that will be combined to form each standard: practices, cross-cutting concepts, and disciplinary core ideas. The practices describe behaviors that scientists engage in as they investigate and build models and theories about the natural world and the key set of engineering practices that engineers use as they design and build models and systems. The NRC uses the term practices instead of a term like skills to emphasize that engaging in scientific investigation requires not only skill, but also knowledge that is specific to each practice. Part of the NRC's intent is to better explain and extend what is meant by inquiry in science and the range of cognitive, social, and physical practices that it requires. Although engineering design is similar to scientific inquiry, there are significant differences. For example, scientific inquiry involves the formulation of a question that can be answered through investigation, while engineering design involves the formulation of a problem that can be solved through design. Strengthening the engineering aspects of the next generation science standards will clarify for students the relevance of science, technology, engineering, and mathematics, the four STEM fields, to everyday life. The cross-cutting concepts unify the study of science through their common application across science and engineering. Cross-cutting concepts have application across all domains of science. As such, they are a way of linking the different domains of science. The framework emphasizes that these concepts need to be made explicit for students because they provide an organizational schema for interrelating knowledge from various science fields into a coherent and scientifically based view of the world. The overarching goal of the framework in NGSS is for students to have sufficient knowledge of science and engineering to engage in public discussions on science, related issues, be careful consumers of scientific and technical information, and enter the careers of their choice. Disciplinary core ideas have the power to focus K-12 science curriculum, instruction, and assessments on the most important aspects of science. To be considered core, the ideas should meet at least two of the following criteria, and ideally all four. 1. Have broad importance across multiple sciences or engineering disciplines, or be a key organizing concept of a single discipline. 2. Provide a key tool for understanding or investigating more complex ideas and solving problems. 3. Relate to the interest and life experiences of students or be connected to societal or personal concerns that require scientific or technological knowledge. 4. Be teachable and learnable over multiple grades at increasing levels of depth and sophistication. Disciplinary ideas are grouped in 4 domains: the physical sciences, the life sciences, the earth and space sciences, and engineering, technology, and applications of science. Let's watch this video as science teachers learn about the NGSS. How are the NGSS structured? Expressed as performance expectations, integrate practices, core ideas, and cross-cutting concepts, statements of what is to be assessed, require demonstration of knowledge in use, not instructional strategies, not lesson objectives, state what students should be able to do at the end of instruction, and organized by topic and by disciplinary core ideas. Performance expectations define what is to be assessed. Here's an example of one. What are the key shifts of the NGSS? 1. Developing explanations and designing solutions supported by evidence-based thinking. 2. Link learning to phenomena, systems thinking and modeling. 3. Investigating, solving problems, and engaging in discussions with teacher guidance. 4. Students addressing open-ended questions, use of evidence to generate claims. 5. Using multiple sources of evidence, not just textbooks. 6. Investigations driven by student questions. 7. Students writing that explains and argues. And 8. Equal access to all students, student supports. Here's another activity. Let's explore the NextGen website so you know some of the resources you have available to you as you learn about and implement the NGSS. In your explanation of the NextGen website, did you read the Frequently Asked Questions section? Valuable information is summarized in this section of the website. Here are some of the many publications that will support you as you learn more about the NGSS. Here are some additional resources.